Compact conductors are engineered to decrease the overall diameter and weight of conductors while preserving the same electrical performance as standard conductors. These conductors find common application in overhead transmission lines, where they enhance transmission efficiency and curtail costs. The fabrication of compact conductors involves compressing multiple strands of conductor material into a compact round configuration. The compression of strands can be achieved using several techniques. Firstly, concentric lay, where the strands are organized in a concentric pattern. Multiple layers of strands are wrapped around a central core in this arrangement. Secondly, the sectoral arrangement, where the strands are arranged in a sector shape, with multiple sectors of strands forming a round conductor. Thirdly, the trapezoidal arrangement, where the strands are arranged in a trapezoidal shape. The strands in each sector create a trapezoidal cross-section. Fourthly, shape optimized. The strands are arranged in a shape specifically designed to minimize the overall conductor diameter and weight while maintaining electrical performance. Following compression, the strands typically receive a thin layer of insulation. This insulation shields the conductor from moisture and corrosion. Insulation materials can encompass cross-linked polyethylene, abbreviated as XLPE, thermoplastic polyethylene, abbreviated as TPU, or ethylene propylene diene monomer, abbreviated as EPDM. Compact conductors present several advantages when compared to standard conductors. A reduction in conductor diameter and weight occurs, which can translate to lower installation and maintenance expenses. Improved transmission efficiency is achieved, enabling an increase in the capacity of overhead lines. Wind loading is reduced, enhancing line stability. Ice shedding properties are enhanced, diminishing the likelihood of outages caused by ice accumulation. These factors collectively contribute to the enhanced performance and cost-effectiveness of compact conductors and power transmission systems. The specific design of the compact conductor, including the strand arrangement and insulation material, is selected based on the intended application and performance requirements. Considerations such as voltage levels, current carrying capacity, environmental conditions, and mechanical stress influence the design choices. The use of compact conductors has grown in recent years as utilities seek to optimize their transmission infrastructure and reduce costs. By minimizing conductor size and weight, it is possible to build more efficient and resilient power grids. Furthermore, the improved ice-shedding properties of compact conductors make them well suited for regions prone to severe weather conditions. The insulation materials used in compact conductors play a crucial role in ensuring reliable operation. XLPE, TPU, and EPDM are all known for their excellent electrical insulation properties, resistance to moisture, and durability. These materials can withstand the high voltages and harsh environmental conditions encountered in overhead transmission lines. The selection of insulation material depends on factors such as operating temperature, voltage stress, and chemical exposure. In addition to the materials and manufacturing processes, the installation of compact conductors requires specialized techniques and equipment. Due to their reduced diameter and increased flexibility, compact conductors can be easier to handle and install compared to standard conductors. However, care must be taken to ensure proper tensioning and support to prevent sagging or damage to the conductor. Regular inspection and maintenance are also essential to ensure the long-term reliability of compact conductors. This includes visual inspections to detect any signs of wear, corrosion, or damage to the insulation. Periodic testing may also be performed to assess the electrical performance of the conductor and identify any potential problems. When working with compact conductors, it is important to adhere to all applicable safety regulations and industry standards. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and following established procedures for handling and installing conductors. Proper grounding and bonding are also crucial to prevent electrical hazards. The design and construction of overhead transmission lines using compact conductors is a complex process that requires the expertise of qualified engineers and technicians. Factors such as conductor spacing, tower height, and insulation coordination must be carefully considered to ensure the safety and reliability of the system. Computer modeling and simulation tools are often used to analyze the performance of transmission lines and optimize the design. The use of compact conductors is just one example of the ongoing innovation in the field of power transmission. Researchers and engineers are constantly developing new materials, designs, and technologies to improve the efficiency, reliability, and sustainability of electrical grids. These advancements are essential to meeting the growing demand for electricity while minimizing environmental impact. Compact conductors represent a significant advancement in conductor technology. Their reduced size and weight, improved transmission efficiency, and enhanced ice shedding properties make them a valuable tool for utilities seeking to optimize their transmission infrastructure. As the demand for electricity continues to grow, compact conductors will likely play an increasingly important role in ensuring a reliable and sustainable power supply. Compact conductors offer a compelling solution for modernizing power grids and enhancing their performance. Their development and implementation reflect a commitment to innovation and a desire to meet the evolving challenges of the energy industry. By understanding the principles behind compact conductor design and application, engineers and technicians can contribute to the advancement of efficient and reliable power transmission systems. The continuous improvement and optimization of conductor technology will be crucial to supporting the growing demand for electricity while minimizing environmental impact and ensuring a sustainable energy future. As technology advances, we can expect to see even more innovative conductor designs and materials emerge, further enhancing the performance and efficiency of power grids. Understanding the fundamentals of compact conductors provides a solid foundation for exploring these future developments and contributing to the ongoing evolution of the energy industry. The benefits of compact conductors extend beyond just the technical aspects of power transmission. By reducing the physical footprint of overhead lines, compact conductors can also help to minimize the visual impact of power infrastructure on the landscape. This can be particularly important in areas with sensitive environmental or aesthetic considerations. Furthermore, the reduced weight of compact conductors can lead to lower construction costs and reduced environmental impact during the installation process. Less material is required for towers and foundations, and the lighter conductors can be transported and handled more easily. These factors can contribute to a more sustainable and cost-effective approach to power grid development. The implementation of compact conductors often involves a careful evaluation of the existing infrastructure and the specific needs of the power system. In some cases, it may be possible to replace existing conductors with compact conductors on the same towers, increasing the capacity of the line without the need for major construction. In other cases, new towers may be required to accommodate the increased voltage or current carrying capacity of the compact conductors. A thorough engineering analysis is essential to determine the optimal approach for each project. The use of compact conductors also has implications for the protection and control systems of the power grid. The reduced impedance of compact conductors can affect the fault current levels and the performance of protective relays. It is important to carefully coordinate the protection system to ensure that faults are detected and cleared quickly and reliably. Advanced control systems may also be used to optimize the flow of power on transmission lines with compact conductors, maximizing their capacity and efficiency. The ongoing research and development in the field of compact conductors is focused on improving their performance, reducing their cost, and enhancing their environmental sustainability. New materials and manufacturing processes are being explored to further reduce the weight and diameter of conductors while maintaining their strength and conductivity. Research is also being conducted on new insulation materials that can withstand higher temperatures and voltages, allowing for even greater power transmission capacity. The development of smart grid technologies is also playing a role in the advancement of compact conductor technology. Smart grids use sensors, communication networks, and advanced control algorithms to optimize the operation of the power grid. Compact conductors can be integrated into smart grid systems to provide real-time data on conductor temperature, sag, and tension, allowing for more efficient and reliable operation. This data can also be used to predict potential problems and schedule maintenance before outages occur. The future of compact conductor technology is bright, with ongoing research and development paving the way for even more efficient, reliable, and sustainable power grids. By embracing innovation and investing in new technologies, the energy industry can meet the growing demand for electricity while minimizing environmental impact and ensuring a secure and affordable energy future. The utilization of compact conductors represents a forward-thinking strategy for modernizing electrical infrastructure and enhancing overall system performance. Their adoption aligns with the broader goals of improving energy efficiency, reducing carbon emissions, and creating a more resilient and sustainable power grid. By embracing these advanced technologies, the energy industry can ensure a reliable and affordable power supply for future generations. Compact conductors are not just a technological advancement, they are a key component of a more sustainable and efficient energy future. Their development and implementation reflect a commitment to innovation and a desire to create a better world for all. The principles of compact conductor design can be applied to a wide range of applications, from overhead transmission lines to underground cables and even electrical wiring in buildings. The underlying goal is always the same: to maximize the efficiency and reliability of electrical power delivery while minimizing the cost and environmental impact. By understanding these principles, engineers and technicians can make informed decisions about the selection and application of conductors in a variety of settings. The use of compact conductors also has implications for the training and education of electrical workers. It is important for electricians and line workers to be familiar with the proper techniques for handling, installing, and maintaining compact conductors. This requires specialized training and certification programs that cover the unique characteristics of these conductors. By investing in the training of electrical workers, the industry can ensure that compact conductors are installed and maintained safely and effectively. The benefits of compact conductors are not limited to developed countries. In developing countries, compact conductors can play a crucial role in expanding access to electricity and improving the reliability of power grids. The reduced cost and weight of compact conductors can make them a more affordable option for building new transmission lines and upgrading existing infrastructure. This can help to bring electricity to remote areas and improve the quality of life for millions of people. The use of compact conductors is a global trend that is being driven by the increasing demand for electricity and the growing awareness of the need for sustainable energy solutions. As more countries invest in modernizing their power grids, compact conductors will likely play an increasingly important role in ensuring a reliable and affordable power supply for all.